So we are now going to talk about another graph traversal algorithm, which is called depth first search, or the DFS. Right? So it is an interesting recursive algorithm used for traversing the graph. So this starts from a node called the source node, and this will pick one vertex which is not visited, and it will visit it. Again, it will pick one vertex from that node which is not visited, and will visit it. So this is repeated, and my recursion goes deeper into a branch until we reach a vertex where we cannot go further. So what happens is, let's say I'm starting from this node 0. So I am currently at this node 0, and now this has been visited. Again, now this can call either to the 1 or to the 4. So it will pick one node which is not visited. So we pick 1, it's visited now. Again, it will call to one node which is not visited. We pick 2, it's visited now. I will explore one neighbor of 2 which is not visited. Right? In DFS we used to explore all neighbors, but here we will explore only one neighbor. Let's say my algorithm goes to the branch 4. This node is now visited, and let's say this will now go to 3. This is again visited, and from 3 it will go to 5. So we reached a point where we cannot go further. So the recursive call will come back. We will return from this. Again, from 3 I do not see any other node which is not yet visited, because from 3 I can go to 2, but 2 is visited. I can go to 4, which is already visited, so I will come back. Again, from 4 I cannot find another node which is not visited. I come back. Again I come back, and again I come back, and finally from 0 I return to the main. So the output is 0, 1, 2, 4, 3, 5. So this is one output. There could be a different output depending upon the order in which we have stored the nodes in the adjacency list. So multiple orderings are possible. So this is one possible ordering of the DFS. Another thing could be from 0 you went to this node, from 0 you went to 4, and from 4 you went to 3, again you went to 5, you came back here, you went to 2, you went to 1, you could not find another node which is not visited, you came back to 3, you came back to 4, and you came back to 0. This could be also a possible output. So this could be another output: 0, 4, 3, 5, then 2, and then 1. Right? So to implement this algorithm, we need two things. One is the recursive call on the unvisited node, and second thing is an array or a map to maintain which node is visited and which is not. Array or a map to maintain the information of nodes which are being visited. Right? So let's see in the code how we can implement this algorithm. Right? So I'm going to make one function, void DFS, which takes the starting point, source node, and we will initiate the DFS call. So this is a wrapper function. We will make one map here, and let's name it visited. Right? So initially all the values are false by default in the map, so I do not need to explicitly set it. Then we will make one more function called the DFS helper, and we will pass it the source as well as some other nodes. Let's pass it some more information, and this visited array. Right? So this is the actual recursive function which will be used. Right? So void DFS helper is one function which takes the node source, and this also takes the map. Right? So map of the type D, bool, and by reference we are taking visited. So whenever I come to a node, or let's say this is the current node, right? So whenever you come to a node, mark it visited, right? Mark it visited, because we do not need to explore that node again. So visited of current node becomes equal to true, and we have to also print it. Let's print that node also, and now we will try to find out a node which is neighbor of current node and not yet visited. So I can say for a neighbor belonging to the adjacency list of current node, if neighbor is not visited, if the neighbor is not visited, then we will visit it. So how do we visit it? We visit it using recursion. So I can call DFS helper on neighbor, and I give the visited map. So that's it. That's how this algorithm works. Right? So let's try to run it on our graph. So I have initiated the DFS call from 0, and yeah. So let's build our program. So a colon here. So the output is 0, 1, 2, 4, 3, 5. So let's see here. 0, 1, 2, 4, 3, 5. Yeah, so it is same as this output. So it means our algorithm is correct. So very simple, very short algorithm. Thanks for watching, and see you in the next video.